ladies and gentlemen. Today we are going to do a couple of dissections in case you've missed the dissection. This is obviously the eyeball dissection. Just to start, the outside of the eyeball has some fatty tissue on it. And the fatty tissue would be like the soft tissue around your eye here that acts as a cushion so that if you get hit in the eye, it actually softens the blow so that your eye doesn't pop out. And your eye can't pop out, by the way. There are muscles around the eye, right in here. They kind of turn that brown cooked meat color when they sat in the formalin. And these muscles allow you to do the things that your parents hate the most, and that's to roll your eyes at them. These cows have 6 muscles around their eyes, all the way around. Now, this is I find this really cool. If you zoom in, zoom in, zoom in, you'll see this little circular white blob right here. Any guesses what that beautiful circular white blob might be? Well, if you've already guessed, it is the optic nerve. And this nerve right here extends into the brain, to the part of your brain that actually senses and knows and understands how to interpret the pictures that you're seeing. And this is the conduit that connects the eyeball with your optic center in your brain. So, the exterior of the eye, fat, muscle, this is the cow's eyelid right here that would stretch down to clean the cornea. Part of it is already peeled off. The lower eyelid is here, it's been cut off. And I've just said the word cornea. Now in the pictures that you'll see, the cornea itself is clear, and your cornea is clear unless, you're dead. Hopefully not. The cornea is milky because as soon as the cow dies, blood circulation stops to the cornea and it goes cloudy. Like zombies, they'll have cloudy eyes. Okay, so I'm just going to start by taking the scalpel. I'm going to put a little nick in the corner of the cornea so it's just through. It's very thick. And a cow's cornea is thick because when a cow is bending down to eat food, there's a good chance that they could get poked in the eye. So I'm trying to catch the aqueous humor here. It's the stuff, the cushioning fluid between the cornea and the lens. You can see some fluid coming out. There we go. Aqueous humor, watery humor. So I'm just going to continue to cut and let the aqueous humor drip out. There we go. Right through the cornea. You can see it's not easy to cut with the scalpel, and I'm using my scalpel like a pencil and just sliding it underneath. On the edge. And once we're done, we'll have the cornea removed, the aqueous humor collected, and we'll move on. There we go. The cornea. This is the part of your eye that if you're getting laser eye surgery, they're going to cut this off, flip it back, well, not cut it off totally, cut it around like I did, flip it back, and they're going to adjust the shape of your lens with a laser. So there's the cornea, and my labeled cornea spot. And there's the aqueous humor, and that's the watery humor that cushions the front of the cornea so it doesn't stick back onto the iris or onto the lens. So now we've got the eye opened, and you can see the colored part of the eye right here, which is called the iris. The iris. And it has the ability to open and close to allow different amounts of light into the lens. The center part of this cow's eye, you can see, kind of looks like a box. And humans, it's a perfectly round hole. And in cats, you think about their pupil, it's more of a slit. So it would be like this would be closed and vertical. So there we go. We've got iris, which is the colored part, cornea, aqueous humor, and now we're going to do something really cool. I'm going to cut the eye in half this way. Behind, about halfway down the eyeball. I'm just doing gentle cuts, so I'm not going too quickly. And see, I'm holding the scalpel between my middle finger and my thumb with my forefinger on top. Just making a gentle cut till I'm about a little bit more than 3/4 of the way around the eye. It'll be as straight as possible because when you get through, you're going to see, and it's tough because this part, this white part, is the sclera, and it's a tough protective coating as well. Just keep it in there to see what's going all the way around, cutting through that fatty tissue, cutting through the muscles that allow the cow to roll its eyes. And out comes our next humor. Super cool. It is the vitreous humor, or glass-like humor. So here we go. See, the vitreous humor is attached to the retina at the back, to the iris at the front. Just using my fingers to gently loosen the vitreous humor. And there we go. So you can see it's got that same jelly-like albumin, like the egg whites, how they're jelly-like. And it actually has this because it has to keep the eyeball shape. It's like jello holding the eyeball in its proper shape. And I'm just going to loosen it as much as I can. From the retina, which is that filmy looking stuff back there, that's the retina. And there we go. Some of the retina materials in there in the vitreous humor. I'm just going to flatten out the retina. So you get a sense of it covering the back of the eye. There we go. That is the retina, and that's covered with your rods and cones, the cones sensing color, the rods sensing lightness and darkness. And on this side we see the lens, and inside and around the lens is the muscles, the ciliary muscles that control the shape of the iris. So, next thing we're going to do is we're just going to pop the lens right out of the iris. And now we've got the lens in our hands. Now you will have studied optics by now, and you will have studied the shapes of lenses. And this has a biconvex lens shape. Now, you all know that a biconvex lens is very much like a magnifying glass, so we're just going to see if it actually works. Well, it's shaped the same as this lens here, a biconvex lens. So let's see what a biconvex lens does when put over top of it. It's like a magnifying glass. It is refracting the light to a single focal point. And in this case, in the eye, it's refracting the light onto the light-sensitive cells at the back of the eye. So there we go. The lens of the eye. So let's go back once again to our cow's eye. Looking at it from the front, we've removed the lens now. So as the light enters the eye, it would be bent when it comes through the cornea, bent when it comes through the aqueous humor, bent some more when it goes through the lens, then bent some more as it passes through the jelly-like vitreous humor, and finally the light would arrive onto the back of the eye, onto the light-sensitive cells of the retina. Now, if you look very carefully, you'll see that all of the light-sensitive cells seem to be attached at a single point here. And as I remove the retina very slowly, going to see that there's a single attachment point right here. That attachment point is what you might remember, you might know as the blind spot. Because the lens has to, the retina has to have a place where it attaches to the back of the eye, it actually has a hole where there's no light-sensitive cells. So to prove that to you, this on the retina, I'm going to unravel it until you can see. That is the blind spot. Everybody's eyes has one, including you, not just cows. All right, so now we've done cornea, aqueous humor, lens, vitreous humor, lands on the light-sensitive cells in the back of the retina, goes through to the optic nerve. So just for interest's sake, we're actually going to cut the optic nerve right off, and you get to see that it's actually this perfect round nerve. Nerves are most often in a round shape, like a tube or a bundle of nerve cells. And there you go, a nice round optic nerve. So, optic nerve, blind spot is there in the retina. So we have, still there's some words on here. We've got sclera, muscles, iris, tapetum, and a blind spot. We know the blind spot. Well, this cow eyeball doesn't have the greatest muscles, but we can cut some of the muscles off. Muscles are long fibers, and they allow the cow to have control. 6 muscles around the cow's eye. Oh, sorry, 6 muscles around the human's eye. See, cows should be able to roll their eyes even better at their parents. There's some muscle. And let's get at the iris. Flip this right inside out so you can look through. Looking through the perspective of the cow's eye. So this is the iris here, and it is controlled by ciliary muscles. Flip that inside out. Try to get the iris off. You can see it almost looks feathery, the iris. Look, this cow had brown eyes. Look, all the cows have brown eyes. Oh, there we go. Let's try the cow. The featheriness are those ciliary muscles that allow the iris to open and close to adjust the amount of light entering or leaving entering the eye. There we go. That is the colored part of the eye. You get your iris color from your parents. It's a genetically passed on trait. And the stuff that's left over, this hard, tough stuff that's been really difficult to cut through, is called the sclera. It forms the outside of your eyeball, holds everything in place, makes sure that everything is in the right pressure inside your eye. We still have something left over that humans don't have in their eyes. It's called the tapetum, and it's a layer of reflective material at the back of the eye. I don't know if I'll be able to get this tapetum off. Sometimes. And what it does is when the light enters through the cornea, through the aqueous humor, through the lens, through the vitreous humor, and lands on the retina, the tapetum is behind the retina, and it's shiny, it's reflective. And as you all know, because of reflection, if it's shiny and reflective, it bounces the light back through the retina a second time. And what that does is, it means that the cow can see in lower light levels. So any animal that has that super glossy, shiny eyeball, think of deer, think of a cat, they have a tapetum to help them see in lower light levels. Probably because they don't have as many rods and, as many cones as we have. And cones help us see color. And here comes the tapetum. And most people will be grossed out by this, pulling the cow's eye apart, but it's not bad. Let's feel the parts. And then you're able to clearly see that blind spot, where the spot would be, where all of the parts attach into the back of the eye. And there's the attachment point for the optic nerve on the very back of the sclera. So this is the back part. It's also called sclera. It's very tough. You can't grip it easily, and it's to keep your eyeball shaped. So I hope you've learned something. I want you to think about that refraction happens many times when the light enters the eye. It'll be refracted through the cornea, through the aqueous humor, then into the lens, then into the vitreous humor. All of those times bending in order to land on the light-sensitive cells of the retina to pass through the optic nerve into your brain. So I hope you learned something, and we'll be doing some more dissections.